Good evening, everybody. Can you hear me?
Yes.
Okay, so let's get started. So in the last class, we discussed about what is Git, why we need Git kind of source code management tool, and we also discussed about Git architecture, right? Let me see if we have that slide. Okay. So today, let's see how we can install Git. Okay, Git installation. You know how to install something in Linux machines, right? Can you tell me the command? What is the command using which we can install something?
Yum.
apt get update. Okay. So yum is for CentOS and RHEL.
Okay.
In Ubuntu is apt get. Everybody. So we also have yum. So if you have CentOS or RHEL Linux, then we use yum. Yum update, yum install. In Ubuntu, equivalent command is apt get. So apt get update sudo. Then just say apt get install git. That's how we install anything in Ubuntu. So once apt get update is done, then just say apt get install git, apt get install git, apt get install maven, apt get install Java and so on. So in my case, since Git is already latest, right? Since it is already installed and then latest, it's not installing again. In your case, it will take some time and then you should be able to see Git installation. Okay. So once this command is executed successfully, you can check where Git is installed. You can see, which Git, which is a Linux. So if you want to know where a particular command is installed, use which Git. For example, which Maven, which Java. So you can use which command for install location. For example, say this with Java. Java is installed under user/bin. Which Maven? Maven is already installed my mission. User bin. So that's how you check the path of a particular command. And if you want to know the version, just say git version. Okay. So I have 2.25 version of Git. That's how we install Git. Simple. Okay. And if you want to uninstall Git, just say apt get remove Git. So I've given all the commands here. Simple, right? Any questions about installation?
Sir, in email shows 1.2.43 something, but in your system it shows something else.
What is it showing in your mission?
In my it shows version 1:2.43.
1:2.43.
Yeah, or two for you it's a 2.5.
What command you said you typed? Git.
Sudo apt install git.
No, for checking the version, what command you have used? Git version or something else?
Git sudo. Okay, sudo you used, right? So I also used sudo apt install git. That's what I typed.
First execute sudo apt-get update, then apt-get install git.
Okay.
apt-get update will bring the updated one, latest one.
Yeah, but 1:2.43 is what my mind showing. For you showing 1:2.25.
Same
So
for
which
me,
is
Satish, 2.43 for me also. I think, sir, your version is behind us.
Git hyphen version. Git version. Which one you have, Raj?
2.43. I put it in the chat also.
2.43.
Yes, sir.
Okay. So then this is the little older one. That's okay, fine, no issues.
Okay.
So this is our remote repository, right? This is the Git server. This is your repository. We call this the repository. Repository will have a name, right? For example, let me call it as Flipkart. I'm working for Flipkart. So this repository I'm creating for Flipkart project. So in the repository will be having code, right? Assume that you have 10,000 files here, application code. One file called login.java, for example. So how do we work usually? So if you want to work with Git, we first have to clone this repository, correct? So for example, you are a DevOps engineer. You joined in this, Flipkart project, for example. So you want to modify something, some DevOps related code. What do you do first? We have to clone the code. First step is clone. We know this. So once you clone, what will happen? Tell me. It will create a directory in your laptop. So matching your repository name. What is the repository name? Flipkart. So it will create a repository called Flipkart. Inside this Flipkart, it will get another directory called .git. We call this as a local repository. What do you call this? Local repository. So if you have 10,000 files in the remote repository, same 10,000 files you get in your local repository. This is your remote, correct? We know this. Assume that you have login.java here. So you'll get login.java. So this .git is exactly cloned copy of remote repository. But as we know, we cannot directly modify the file in local repository, correct? Because it is in its own understandable format. So that is the reason Git gives us another copy in the source area. Think it as a directory, okay? And there is another directory called staging. You have to virtually, assume it. I'll explain this later to you. So we have source, stage, and then local repository. So once the clone is in, what do we do? Then we modify the file. Where do we modify the file? Can we directly modify the file in the local repository? No, right? We modify the file in the source area here. And then we have to move that particular file, add that particular file from source to staging area. Modify or create a new file. Here, you can modify your existing file or you can create a new one. And then you have to add that particular file to stage. Then you have to commit it, correct? So I'm committing it. Once you commit, tell me what will happen. It will get a separate copy, correct? So this is a old copy, new one, old one, say for example, 1. And then it also stores who modified the code, what time it is modified, why it is modified, and things like that. So you're committing it to local repository first. From local repository, you can push it to remote repository. So when you say git push, for example, the same change will go to the remote repository. This is called the commit. First commit, second commit. So you have one, and then you have second commit. From now onwards, if anybody clones the repository, they get the latest file. That is your copy. That's how it works. Correct? Okay. So before you run all these commands, you need to have a remote repository, correct? Let's create a remote repository first. Let's create a remote repository, this one. So there are two ways to create a remote repository. One, on-premise or you can create remote repository in cloud. Anything is fine. So this is called as on-premise, for example. What is that? On-premise. On-premise means this is your own mission. Okay, this is your own server. You take a mission from your office, and then you can create a repository here using some Git commands. This is your remote repository. You can do that. Remote repo. But usually we don't prefer to create our own repository. That means on-premise. On-premise means it is in your server. Because see, if you know, since this is your own repository, right? Since you created it, you have to maintain it, right? Maintain means you may need to have a separate system administrator. You may need to have separate DevOps engineer, for example, to take the backup of the code, backup of the repository. You may need to have separate networking, engineer, networking specialist to manage, the network connections to this particular, repository. And you may need to have some special hardware, right? Some enterprise hardware to, for better performance, for example, and so on. So it costs a lot for you. So that is the reason usually we don't create repository on our own machine and then manage it, because a lot of maintenance issues. That's where we think the cloud, correct? We have something called GitHub. What is that? GitHub is a cloud. Okay. They say instead of you creating the repository and then getting into the maintenance issue, come to GitHub and then create your own repository. That means we can go to their mission. Think this as a GitHub's mission. Okay. So they say you create the repository. Since we are creating the repository in their missions and then they are managing it, we have to pay for them, right? That's a cloud concept, correct? GitHub is a cloud solution for Git. So they charge for that. They say you have to pay for us, pay to us, you have to pay us basically for maintaining the remote repository, correct? And it's very less, $7 per month. $7 per month for companies is very less, correct? Of course, if you use different services, they charge differently, but for basic repository creation, right, they charge $7. So if we create the repository in GitHub, we don't need to have separate DevOps engineers, separate network engineers, system administrator, hardware, and so on. So they make sure that repository is up and running always and it is stable no matter what. So that is the reason usually we go and create the repository in GitHub kind of cloud platforms. That's their business. Similar to GitHub, there is something called GitLab. It is another company. There is something called Bitbucket. They're all into the same business. GitHub is very popular. Okay, so it was started as an independent company. Then, I think 4 or 5 years back, Microsoft acquired this GitHub. So now it is with Microsoft. So usually we create a repository in GitHub or GitLab or Bitbucket. And it's not just about the maintenance, right? They also give you an application called github.com. What is it? github.com. So if you go to github.com, http:// for example, you can see your repository here. You can see your repository, you can do a lot of things with a simple, mouse clicks. This is an application. Understand this? I'll show this to you later. I mean, now. If you have the repository in GitHub, right, you can also browse your repository content from the browser. That means you can do a lot of things, graphically from this github.com application. If you have your own, repository, so you may need to have a separate, development team to create this kind of applications. So it's very difficult. You need to have, you need to spend a lot of budget. So that is the reason usually we go and then create repository in GitHub kind of, cloud place. Okay. So I'm going to show you the repository creation in GitHub. if at all you have to create repository on premise, you have some commands in your Pro Git book. If you want, you can try, but it's not required. Very rarely companies have their own repository. For example, some finance applications, banking applications, right? They don't want to take any risk. They don't want to take even 0.001% risk. That's the reason they have their own repository, because they don't want to store their application code in some others mission. Doesn't mean that GitHub is not secure. It's very secure. GitHub's own employees also cannot see anything, and there will be a lot of agreements about the security and things like that. So you don't need to worry about that. Say for example, you have Aadhaar project, right? Aadhaar project is very sensitive, so we don't want to store Aadhaar application code in somewhere, some other mission, right? If something happens, say for example, whole country, data is leaked, right? So a lot of issues there. So very, few companies, use on-premise repository. Otherwise, I would say 95% of the companies go to, GitHub kind of cloud place. Okay. If you don't have any other questions, I'll go ahead and then create a repository. Any questions you have? Any questions? Okay, see this. So we want to create a repository. Go to github.com. Just type github.com. Okay. You need to have your own repository, because all the command for practicing purpose, you need to have some repository, right? So go and then create the repository. If you are a first-time user, sign up. I've given all the steps here. Create an account in github.com, right? Login and things like that. If you want to take running notes, you take it. Or just see what I'm doing. Okay. So you can give your name, something like this. Okay. Then give the password here. It will ask your email ID, and then something like this. Something like this. And then give a password and then validate your email ID. Account is created. Sign in. This is my username and then password. Sign in. So I have two-step authentication enabled. 1 second. So I'm into github.com. Okay. See, this is an application. Okay. I can see all my repositories here, and I can do a lot of things with the mouse click. So developers usually developers and then other users feel very easy to work with github.com. Say for example, I want to create a new repository. Okay. In your case, you will see empty page. You want to create a new repository, very simple. New. See how easily I'm able to create the repository, right? With mouse clicks. If you have on-premise, then you may need to have you need to execute maybe 10-15 commands. So things are a little difficult there. Since we are using github.com, right? Creating or working with Git it becomes very easy. So if you want to create a new repository, click on new. Give some name. Okay. So this is your username. Usually we use a project name. Okay. Say Flipkart 61. There is a repository with Flipkart already. So just to make it unique, I'm just adding some number. Flipkart. Okay. That's a repository name. You can give some description of your project. Online learning platform, something like that. Or let me create Y30, okay? Y3061, for example. Online learning platform. Then you have two options here: public repository, private repository. So a repository can be public or private. Say, for example, you create a private repository. Private repository means anybody in the world can clone the code, clone your repository, and then see your code. Since it is a public repository, anybody can see the code. Okay, they can clone, but without your permission, they cannot modify and then submit, even though it is public. So you can, if somebody wants to push something to the public repository, you have to add their name. Okay, you have to give permission to them. So usually in real time, we don't create public repositories, but open source projects do use public repositories. In organizations, we use private repository. If it is a private repository, without your permission, nobody can take the code, nobody can see the code, nobody can modify and then submit the code. So that is the only difference. Otherwise, both are same. Let me go and then create a private repository. You can also create one private repository for free. You can create one private repository for free in GitHub. Okay. So public, anything, you just need to select either any one, public or private, and then just say create repository. That's all. Repository creation is done. We can take. Okay. And this is your URL. Can you remember the URL now? It is github.com. Okay. Your username and then repository name, faculty.git. Remember, remote repositories always end with .git. Remote repositories always end with .git. Okay, so you joined as a, you joined in a startup, say for example. Okay, and then you have a new team. Your manager comes to you and says, comes to you and then asks you to create a new repository. So this is how you create a repository. Once the repository creation is done, then what do you do? Just send this URL to your team members and they can start pushing the code to your repository, right? So that's how you create a new repository. Now we have our own repository, right? Called say faculty, right? So now if you want to work with this repository, what do? We have to first clone it, right? So for example, once the repository is created, you sent an email to your team member saying, hello all, I have just created a new repository. You can start working with this repository. So this guy is Harry. Okay. Let's see how Harry or anybody works with this new repository. Repository name is faculty. Okay. So first step is clone, right? So I'm cloning the repository. This is how you practice. You practice in your, lab machine, local machine first. Same thing you're going to do in real time as a DevOps engineer. I don't have anything. Go to some directory. Okay. Go to some directory. And then I say git clone. Okay. That's a command. And then repository name. Remember it, https://github.com. Okay. This is my username. And then this is your repository name, faculty61.git. Clear? What clone command does? No matter where you are, okay, where this repository is, think that this particular repository is created somewhere in GitHub's infrastructure. Okay. So git clone downloads the repository. We call it as clone, correct? It clones the repo. See this? faculty61. So the moment you clone it, it will create a directory matching your repository name. Inside this directory, what will be there? .git source stays. Correct? Okay. See, it says there is a warning. You appear to have cloned an empty repository. Yes, we know, right? This is empty repository. There is nothing. It's a new one. So go here, go into y36 one. Okay, cd to it, ls -e, because this is .git, right? .git. So if hidden file or hidden directory, this is hidden directory. So if you want to see directories which start with a dot, then use -e .git. So you know .git, fine. .git is there, right? Where is source area, staging area? There won't be a physical directories called source stage. No. Okay. So you have to think this as a source area. Whatever you see, along with the whatever you see here, other than .git, that's a source area. Think this as a source area. Okay. And staging is kind of a virtual directory. You have to assume that okay, there is a directory called staging somewhere. Okay, somewhere in your machine. So this is your source. .git, and then whatever you see, right? Along with the .git, that is in, you have to think that is in source area. So let me modify something, or I can create something, correct? I want to create a file called login.java here. I'm a developer, okay? ls-a. I clone the code, and then say, for example, Harry calls you. I don't say anything in the repository. You tell Harry, it's a new repository. You're the first one who are commenting something. So Harry is a developer, right? So this guy will create a new file, for example, login.java. When you practice, you create a login.txt or whatever. We are not learning Java or anything here, right? You're learning how you modify something, and then how you commit, how you push it to the remote repository, how you publish your changes to the remote repository is what you're learning, right? Okay. So I just created a file. Okay. I'm Harry. Let's see. I run a command called git status. It says no commit set. We know there are no commits. It says untracked file. Login.java is untracked file. Why it says untracked file? Because this is a new file, right? If it is an existing file, then Git will have some tracking information, right? Who modified it, what time it is modified, why it is modified, and so on, correct? So there's a new file. So that doesn't, it says untracked file. Red color means think that file is in source area. Okay. ls-a. So this is called the source area. You have to think that this as a source area. You may be having, assume that you have 100 files. So you will see 100 files in this source area. We don't directly modify anything inside .git. Okay. So this is in source area. Git status. Git status will give you the status of the files. Status of modified or modified files or new files. You can run git status command any number of times. Okay. So red color means file is in source area. Remember. Now we have to move this particular file from source to stage, correct? What is that command we use? Git add login.java. Simple. Git clone, then git add. Status is just for your information. That's all. Your wish. Whether you want to, if you want to see, what changes you have, you can run git status or not required. Now I'm adding the file to stage area. Enter. Now I want to see where the file is. What is the command I use? Status. See, earlier it was in red color, means the file is in source area. Okay. And now once you add it to the stage, once you run git add command, the git, once you run this git add command, git adds that particular file into staging area. Remember, green color means it is in staging area. Where is that staging area? Somewhere in your mission. Think that, okay, stage is a directory, okay? So whatever you have here, exact copy is in stage. Remember that way. You have this login.java in the source area, right? Think that same copy is in staging area. Okay. So that's how you add the file to the staging area. Git status. This is in staging area because it's in green color. Then I have to commit it, correct? The moment you commit, what will happen? Tell me, since the first change, Git will create a first copy. Okay, it will store the same file in local repository. First commit. So this is the command. Okay, remember git commit -m message commit message. We call this the commit message -m and in double quotes. Okay, you can give some description. Okay, in real time, when when you modify or when you're modifying something or you're getting something, you know the reason, right? Why you're doing that, correct? Why we have to give this commit message? For example, I'll say login module code goes here. Okay. So you have to give the reason. Why you have to give the reason? Because Git needs a reason, right? It stores the username. It will take the name from your mission. Okay, you have to configure it. I'll show this to you later. I already have configured my name. So it is taking that name and it will take the timestamp from your mission. And then it also needs to store the message, right? Why? Who committed it? What time it is committed? Why it is committed? Git doesn't know why you are adding this particular file, right? What is there in this particular file? What you modified in this particular file? So at the time of committing the file, you need to give a reason. Okay. And then file git commit. M means commit message. Remember that way. -m followed by the reason and then file name. That's all. Now the file is committed into local repository. Okay. See this git status. Let's see the status now. It says nothing to commit. Working tree is clean. That means you don't have anything pending in source or staging to be committed. No, you don't have anything, source or stage to be committed into local repository. It says nothing to commit. You don't have any pending things in source or staging data. Working tree is clean. That means no modifications. Okay. Working tree means your files and folders. You'll understand the above messages later. Now, this particular file is still in my local laptop, correct? It is still in my laptop only. You want to see the history of this particular file now? How this commit looks like? Git log file name. That will give you the complete history of a file. Okay, if this file is modified, say like 1,000 times, it will show you 1,000 commits. See here, we have only one commit. First time we committed it, correct? Now you can verify. Okay, see, it is storing the file in the local repository, right? And see, it is maintaining the history of it. Who modified it? Harry. I already configured this user in this mission. I'll explain how to create this user in next topic. So who modified it? Okay. It is storing the name and the email ID also. What time it is modified? Why it is modified? Correct. This is the reason we have given commit message. Right. Okay. And then we know, right? For each and every commit, it will give a number, correct? It will give a number 1. If you commit again 2, 3, 4, 5, and so on. It is not a simple number like 1, 2, 3, 4. Number looks like this. Okay. You call this as revision number, version number, or mostly you call it as commit ID. What's it? Commit ID. Okay. Commit ID. You'll understand how Git generates this commit ID later. So that's how the commit looks like. If you go to your remote repository, right? This is my remote repository, right? I don't have anything here. It's still empty repository. Just refresh it once. It is still empty. Shall we push this particular file to the remote repository now? Okay. ls-a git push. Just say git push. It says invalid user password, authentication failed. Why? I would have done some, changes with respect to the user. It is working. Okay. So run git push. When run git push, what will happen? Tell me. Whatever changes you have in your, whatever modifications you have in your local repository will be pushed to the remote repository. Since we have one commit here, it will store one commit in the remote repository. This is my remote repository username. Okay, this is your GitHub username. Okay, you would have created the user already, right? So this is your GitHub username. Okay, and then it is asking for the password. This is not your GitHub password. No, remember this. You first created an account. If you want to create a repository, you have to go to github.com and create an account, right? So this is your username, whatever you have given. But your GitHub password won't work here. You have to generate the password. You have to generate password. So how do you generate the password? I'll explain that later. So this is my password, okay? So this is my username, okay? I just want to quickly push it. Then I'll explain how you can generate the password. This is my username, okay? Password. Sometimes people call me, sir, I don't see anything here after pasting. It is pasted, okay? Since it's the password, it is not showing you. Enter. It says invalid username or password, okay? Okay, because the password is expired. My password is expired. Shall we generate the password? Okay. So you know how to create a new file or modify the file, add it to the stage, commit it to local repository, and then push it. Git push. Now I need the password, right? So I'm generating the password. Again, these steps are here. Setting up token or password. Just observe what I'm doing. So if you want to create the password, click on this user icon, top right. Go to settings. Then go to developer settings. What is the developer settings or what it is? Yeah, developer settings. Then click on personal access tokens, classic. See, it is expired. That's the reason I was unable to push it. And then just click on this generate new token, classic. It is just asking you to remember, asking some name to remember that token. I'll call it as YKT, something like that. You can set the expiration date also. Okay, 30. And then click on the first one, repo. This will give you all access. Don't change anything, just say generate token. So this is my token, password. Token means password. Copy it and then store somewhere, okay? People do another mistake here. So for example, you are working in Linux machine, right? Correct? Do this in Linux machine laptop, Linux machine browser only. Sometimes what people do, they open the browser from the Windows like this, Okay, they create the repository in the Windows from the Windows browser, and they store the they generate the password and then they store the token in Windows. And whenever you want to push something, you copy the token from the Windows machine, Windows notepad, and then paste it in Linux. Copy paste don't work by default. So you're copying something from Windows, and then if you paste here, what will happen? Tell me. Paste don't work. So even though you are giving the right token, so it says it will complain saying, okay, password is not matching. So make sure that you have the token in your Linux machine so that copy works, copy paste works. So this is my token. Okay, this file is in Linux only. Let me copy this. Paste. So I'm able to successfully push that particular code to remote repository. You want to see that? Just go to your repository. So we created yculti61, correct? That's the repository name. Click on that. This is the repository. And see, you have one file called login.java. Now, anybody in your project can take this particular file. Okay. Let's say, I'm Sally. Okay. Let me delete this clone copy. Because it's just a clone copy, right? So it is just deleted it. Now think that Sally wants to work on the repository. What Sally will do? Think that I'm Sally now. Sally will clone the repository, github.com username and your repository name. And now in remote repository, there is a file, right? There is a file, right? What is the file name? Let's say, see, login.java is there. So Harry modified something and then push something to the remote repository. Now Sally is cloning. When Sally clones, same thing happens, correct? In Sally's mission, it will create a .git. Since there is a file here, it will show the file, the source, in the local repository, staging area, source area. Now Sally can do anything here. Sally can modify the file. Sally can add it to the stage. When Sally commits, it will get a new copy. This is one, say for example, this is 2. And when Sally pushes, what will happen? Her changes will be pushed to the remote repository. Say 2, for example. Think that I'm Sally, okay? I'm Sally. I got existing. I have an existing file. I want to modify it. See what Sally is doing? Sally is a Java developer. Okay. Sally writes something like this: public class login. Something like this. Don't worry about the code. When you practice, just write something like this. Okay. Save and quit. So Sally modified something in the source area. This is it. This is source, correct? Okay. Git status. See this? It says, now it is not saying it's an untracked file. Red color means you have the change in the source area. Remember that. Now, if Sally wants to push it to the remote repository, she has to add that file to staging area, correct? Git add, git status. See, green color means it is in staging area now. And then I'm committing it. Okay, I'm committing it. It will get a new call. How do you commit it? Git commit -m message added class definition, or you can say fixed bug 1, 2, 3, something like that. And then finally, git status. So it says your branch is ahead of origin master by 1 commit. That means you'll understand about this later. Now, for nothing that you have an extra commit here. Okay. Now, what's Sally can do? Git push. It'll ask username and password, and then things are pushed. So in my case, my password is stored in this machine. I've configured that way. I've configured something, I've used some command to store the credentials permanently in my machine, right? So git push. Now what will happen? Tell me. This particular file has how many times this particular file is modified? 2 times, right? See the history now. Git log login.java. This is the first commit. Login module code goes here. This is your second commit. Okay. 1 second. So this is the first commit and this is your second commit. So this is a commit ID. Who modified it? What time it is modified? Why it is modified? Now you can also go to the remote repository and then see that Sal is changed. Just refresh it. See, this is the file name. Click on that file. You can see Sal is changes. This is what we modified, right? If you want to see the complete history, you can click on this history. 2 times, 2 histories, 2 commits it has. This particular file has 2 commits. Login.java. First one, second one. Now again, right? So Sally wants to add another file, new file, for example. We work in source area, we move it to the stage, and then we commit. When you commit, what will happen? Tell me. So this is the third commit, right? Third commit will have whatever you have till second plus 1. That means third commit will have login.java plus form.xml file. And then when you push it, this is 3, it has login.java and then form.xml file. See, it has to, each and every commit will have the previous things plus something extra, correct? Now, if somebody clones the code, for example, if this person clones the code, it has to show all the files, right? So first commit, second commit, third commit. Third commit has 2 files, correct? So it will show the latest login.java and then form.xml file, login form.xml file. So this will have whatever you are having till 2 plus something extra. So now let's assume that Sally is adding new file. Touch form.xml, git status. See how Sally is, checking the status, untracked file. She knows that she's adding this particular file first time. Then open it. She'll add something like this, some file, okay? Git status, git add to the stage, commit it, some message, okay? Build automation code. In real time, you know what, why you modified the file. Just explain in plain, simple English, saying, okay, this is what I have done here. Done. You want to check the log now? Git log form.xml file. See, whatever you have given, that is shown here. So make sure that this is, simple to understand, and that should describe your work. Okay. So for example, right, you committed something. You left for the day. Your evening is their morning, say for example, right? During their time, yours time, for example, there is some issue. They want to know who modified this particular file. What is the command they execute? Git log. And they see the commit message. So give as descriptive as possible. Then what do? Git push. Changes are pushed to a remote repository. Just click on the repository and you can see 2 files in your repository. From now on, if anybody clones the code, they get 2 files. Again, they modify something or they add new file and then they push it. So likewise, multiple users work in the project. That's how they share the code. I modify something and then push it to remote repository. Then you come and then Then you take my code and then you also modify something on top of it, you push it. So that's how, multiple people work. So what you have to do, you also have to create your own repository, and then modify, clone the empty repository, then modify, and then push. That's how you practice all the commands. So if you practice all these commands now, in real time, when you work as a DevOps engineer, you don't need anybody's help, right? So you can very easily work there. Clear with this workflow? People also call it as Git workflow. Clone, first step, modify or create a new file in the source area, add it to the stage, commit it, push it. Any questions here so far?
So one question about add and commit. What exactly is happening in add and commit? So what's the difference?
Okay, well, you mean to, you want to understand why we have to add the file to the stage, correct? Reason.
Yeah.
So I used to explain that in a different way. I was having some wrong understanding about stage, okay? For some reason. So when somebody asked the same question in the last previous batch, I was proved wrong the answer, the way I how I explained. Not completely wrong, little bit or most of it. So maybe 10 years back I would have understood stage in a different way, right? So or they would have modified something in the recent version, some things like that. Let me check it. You got the stage, that's staging area, okay?
Oh, sorry, sir.
You call it as stage or staging area. See, I'll tell you, okay? You can combine multiple changes, at once, and then you can commit something, as a bunch, okay? That's one advantage I know. Selective commit. You can choose which changes to include in a commit. This allows you to group related changes together while leaving others uncommitted. By staging changes, you can ensure that each commit is focused and self-contained. Make it easier to understand the project history. Review changes. You can review and modify what's staged before finalizing the commit. This helps catch mistakes early. Facilitates more organized workflow. Same thing. Okay, see this. Couple of reasons. 1 second. So for example, there is a user, okay? There is a user, Harry. Harry is working on fixing a bug. There is a bug, number is say 123 for example. Harry is working on fixing this particular bug, or Harry is developing some new feature. Harry is developing some new feature. You can go. Harry is developing some new feature. Okay. Feature. Harry modifies 5 files. Harry modifies some files, okay? Say 8 files to fix that particular bug or develop that feature. So how many files are there? Some 8 files, okay? Clear? While he's working on fixing this particular bug or feature. Sometimes you do multitasking, right? So you're working on this particular feature bug. Suddenly somebody comes to you and then asks you to do something else. Something, there is some, issue. You have to fix it urgently. So what do? You modify the file. You modify some other files, right? Now you have some changes related to two things. One is for fixing this bug, and then this is for something else. If you have staging area, what you can do? You can selectively add, for example, you want to say you want to commit, bug 123. You want to commit bug 123. You want to commit changes which are related to this feature or bug 123. If there is a staging, what you can do? You can add all the files related to bug 123 here, correct? Because there is a staging. 8 files you can add here related to staging. So that means you're able to group the things related to that particular issue, bug related to that particular feature. And then you commit. If you commit, tell me, if you commit now, what will happen? So this particular commit will have changes related to bug fix 123 only. Remember, bug fix 123 only. Bug no. This particular commit will have changes related to bug 123, and then you push it. Okay. So this particular commit has, right, all the changes in one place, in one commit. So that will give you the better history, right? That will give you better history. You can also do this. For example, you can also commit 4 files, right? In one commit, 4 files in another commit. Tell me what will happen. So tomorrow, after say 3 years, after 3 years, you want to know what files are modified to fix this particular bug. So assume that, after 3 years, same bug, crops up again. You want to know, right? What files are modified, 3 years back. If your, bug fix changes are scattered across multiple commits, it will become very difficult for you to, know what files are modified and things like that. So that's not a clean history. So we have to commit the code. When you're committing, make sure that you're committing complete code related to one bug fix or related to one feature. So don't do multiple commits about a single bug or feature. There is no fault doing that. But tomorrow, if you want to find all the files related to that particular bug fix, it will become a little difficult. So staging is helping you to separate the changes, correct? That means before you do the actual commit, this is the actual commit. Before you do actual thing, you can test it. You can move it to the stage, and then you can also kind of, it'll help. You can also check the your code and things like that. So basically, stage helps us to group the changes related to one issue. That's what this guy is talking about. Atomic commits. By staging changes, atomic means everything at once, right? You can ensure that each commit is focused, and each commit is focused about it's a self-contained, okay, making it easier to understand the project history. That means the commit has all the changes related to one issue and things like that. There is one more advantage. You can choose which changes to include in a commit. So if there is no staging, then you have the mix and then you cannot commit, correct? So basically, you can group the things together. You can have this file I want, this file I want, this one I want. So you can group the things and then you can commit. So that is the main advantage of having stage. You can review or modify before you commit the code, right? So you can review what is there and things like that. All these are almost related to the same thing that I explained. So just leave it. Clear with staging? Ras, any questions on that?
Yes, sir.
Sir, I
Yes.
have one question.
So basically, you can group the changes, okay? And you can have everything related to one thing in one commit. so that you can check the things very easily tomorrow. Yes, Sadiq.
Sir, I have one question in git add and git commit command. Sir, here you have used git add and the file name. So sometimes we use dot instead of giving file name. So can we use that dot in git commit command also?
Yes, you can do. If you want to commit
okay,
multiple
okay.
changes, you can do that. See this?
Means yeah.
One second. Let everybody understand that question first. So git status. Okay. I hope staging concept is clear now. Any questions you have? Okay. If there is no staging, tell me what will happen. I have some lot of files, right? I cannot commit everything related to one feature in one commit, right? So I have like 8 files, for example. I need to group, right? Otherwise, whatever, I need to commit 8 files. If there is no staging, you have to commit it. One file, one more file, and things like that. Right. Okay. See this? You can also, modify multiple things at the same time. Say I have some changes here. Don't worry about what I'm typing here. Don't worry about the content. I have some change here. I have some change in login.java also. I'm deleting something here. Git status. 2 files. Red color means you have 2 files modified in source area. So login.java and then pom.xml file. 2 files are modified. Okay. Now I want to commit both. What is the command we use? Git add login.java, git add pom.xml. Instead of typing multiple files here, you can directly say dot. Okay. Dot means all the changes in this case. Git status. You have 2 files, right? In the staging area. You want to commit both, say, for example, git commit -m fixed bug, right? Say 1, 2, 3. Okay. And usually we have to give the file name, right? Like this. Instead of giving the file names, you can just use dot. Dot means what? All. Without dot also, you can commit all. You don't need to use even dot also. You can just say, if you don't give anything, it will take all the changes which you have in the stage and it will commit. Dot is not required. You can also use dot, Siddiq.
Yes,
Okay.
sir. Yeah.
So now git status. Since nothing is, since changes are committed, it is not showing you anything here. Now you can push it. Git status. You have one commit pending. Git push. Okay. Right.
Sir, I have one doubt.
1 second, Satish. 1 second. So if you want to permanently store your credentials in your machine, run this command. That command is there in the notes. Okay. If you want to store your Git credentials, use below command. This is the command you have to run. Git config -f global and then credential helper store. Run this command. Hello Git, please configure. Remember that way. Git, please configure something for me. What is that something? Credential helper store means it will store. So if you want to store the credentials, you have to remember this. Okay. Credentials.helper store. Global means for all the repositories. You may be working, for all the repositories, right? So that is it. So once you run this command, it will ask for the password once, then it will store. Next time also it will not ask you. Okay. So this command is already configured in my machine, so it is not asking the password again and again. Satish, question?
Yes, sir. For example, sir, no, like you said, login.java or something, made some changes, and let's say that we did some syntax error. Okay, so we did not notice it. So when we do the commit, so does it proofread, and just in case if there is any error, it would let us know that there's some syntax error or something, so that we will check it again and before committing it.
No. So Git is not your compilers. Git is not your Java compiler. Git doesn't validate anything. You modified something, right? And you are committing. It will just store. That's all. It will store whatever you give. It doesn't know whether you have that file has compilation issues or any issues. No, it is just a place where you store a file. Okay.
So, so in that case, let's say that no, I committed and so that was a mistake. So that file should not be updated. So I want to undo that, after the commit. Okay. So the last changes, whatever, for example, when you go there, it shows like with the last updation, right, along with the notes. So I want to undo that change and go to the previous version. So
You can do that as well, but it is not suggested to undo the things. Okay. So for example, I have login.java here. Again, I modify, I add it to the stage, I created another, commit. Again, I modify, add it to the stage, and then there is another commit. 1, 2, 3. Assume that this particular third one has some mistakes. Assume that you pushed it. Okay, that's fine. So first copy, second copy, third copy. And people are complaining that this particular file has some logic issues or some issues. What do? Don't delete it. Don't delete it, because we want to have the history, right? So we want to know, right, what mistakes were made and things like that. So if you want to fix it, then again you modify the file, add it to the stage, do a new commit. This fourth commit has your fix, correct? So go to and again push it. From now on, if anybody takes the code, it will give the latest one, right? Or if they have already the cloned copy, they will run a command called git pull, which you will learn later. If they run git pull, it will take the latest. So that's how we fix the issues. Okay. So let it have everything, good, bad, and everything. If there is something bad, that's how you fix it. But there is also an option to revert. If you don't want this particular commit, right, you can also revert it. That means there are a couple of other things. You can permanently delete it. You can delete it, or you can also hide it if you want. If you want to quickly fix something. Hide means the commit is there, but it will just bring the previous one back here. So fourth one. So this one will become equal. So this is called a revert. I'll explain this later to you. Satish, there is a topic on that. Let me see.
did you share these notes on Friday?
No, I'll share it right away. Anyway, I explain that usually, as part of this grade. Just noting it down since you are very specific about it. So this is the class notes. 1 second. Can you all see the link in the chat box?
Yes, sir.
So everybody just click on that link. Okay. Click on that link. So once you click on the link, you will come here. You will land on this page. Okay. Click on this code, the green color button. Download zip. Okay. You can download that zip. So download zip, and then you can extract it. So once you extract, this is the zip file. There is option to extract it. Was it disconnected? Can you hear me now?
Yeah.
I don't know when I was disconnected. So I've sent to the link, right? Click on that link and then go to code, download zip. Extract it and then you will see something like this. So once you extract the zip, you will get this. Okay. You'll get a folder and then go to Git, double click on it. So this is your class notes. Clear? Any questions here so far? See this stage. Using this stage option, we can logically group the changes related to a bug fix or feature development. This will help us to track the history of the fix or feature development clearly. This will help us to track the history of the bug fix or future. Right. So today, when you commit, if you commit something from, if you commit something to your repository, it will ask you the username and password. Okay. In my mission, username is already configured. Since you don't have the username configured in your mission, it will throw an error during commit. Okay. Run git commit command. Okay. Since you have not configured your name, see, I'm talking about this name. Okay. Login.java. See, it is taking my name right here, Harry, for example. You have to configure your username and then email ID. Since you don't have the username and email ID configured, it will throw you an error. At the time of commit, when you run git commit, it will not commit your changes. It will not commit your changes. Why? Because you have to tell, right, who you are. You have to tell your email ID to it, correct? So that's the reason you have to configure it. When you see that error, Git will also give you a suggestion. Use this particular command to configure your username and email ID. So try to follow the suggestion and then configure the username and email ID. So I'll also explain that in the next class. If you follow, there will be a suggestion in that error message. Just follow that suggestion and you can configure your username and email ID. If you cannot do it, leave it. I'll explain that in next class. So that's all for today. Any questions you have? Any questions?
So we have to register and create our own login, right?
Yeah.
Okay. Okay, sir. Thanks.
Okay. Thank you, everybody. Good night.
Okay, sir. Good night. Take care.
It